Everyone. This is lesson 7-6 from Algebra 1. And technically the name of the lesson is nth roots, which is a little bit misleading. First of all, that's just kind of a funny name. When I say nth roots, n is just kind of a placeholder for any number of roots you might want to take. So you could take a fourth root, or an eighth root, or a cube root, or even a square root. Those are all the types of math that we're tackling today. But when we talk about like cube roots or fourth roots, we usually use a notation for roots that involves a radical sign, and that's not what we're doing today. Today we're going to be doing like fifth roots and eighth roots and all of that, but we're going to be using this fraction notation for it. So really, the lesson that we're focusing on today is how to work with exponents that are fractions. What does it mean to raise something to a fractional power? So as an example here, what does 32 to the 1/5 power means? This is saying to split 32 into 5 equal factors. That is not the same thing as dividing by 5, okay? Dividing by 5 would split it into 5 equal pieces that if you added back together would give you 32. But when I say the word factors, that means multiplication, okay? Factors means to multiply. So what I'm looking for here is something times something times something times something times something that equals 32, all right? And I want to know what one of those pieces would be, okay? In other words, what to the 5th power would give me 32? So this is essentially the opposite of doing like a power. Okay, it's undoing a power of some kind. So when I ask you these questions, and I'm going to be asking you these questions a lot, there's a few different ways you could go about it, and I've kind of got a list here of some different methods. I don't know that you're going to take the time to figure out like which method am I using today. It's going to be kind of a combination of all of them. But I want you to know that the factor tree method, which we'll get to in just a second, is probably the most mathematical way of doing one of these problems. It's also the most time consuming. So I'm hoping that you'll be able to take some shortcuts using some of these things up here, and then we can also do these in our calculator as well. Speaking of that, let me get that out. So when I say memorize powers, that means can you look at this and know off the top of your head that 2 to the 5th power is 32? For some of these, you can, okay? For some of these, you know, if I gave you 4 to the 1/2 power, I hope that you would know that 2 squared makes 4. So some of these you're going to know very easily, or if you don't now, you're going to know them by the time you do today's homework assignment because you're going to do the same numbers over and over again. Some of them you won't know off the top of your head, okay? The other thing you can do is guess and check. So again, if you know it's something to the power of 5 that makes 32, and if you have a calculator available, that's obviously going to be the easiest way to go about this, is start guessing some things to the power of 5 and see which one makes 32. Okay, so maybe it's 4 to the power of 5. Nope, that comes out to be 1024, so I need something smaller. 3 to the power of 5. All right, that's 243, so maybe I'll try 2 to the power of 5. Oh, there's my winner, so that means my answer would be the 2, okay? So that's what I mean when I say guess and check, is if you know this is the question you're trying to answer, sometimes you can work around it and try to figure out what this number should be. Both of these are kind of fuzzy math, right? These are kind of reliant on some good like background knowledge, knowing your multiplication tables, all of that kind of thing. Factor trees, like I said, are your fallback method. These are the most mathematical, the most reliable way to do it. It just takes a little bit of time. So if I was going to make a factor tree for 32, I'm going to take 32 and think of some way I could multiply to make 32. So 32 I know is 2 times 16. Well, 2 is prime. I can't split that down any farther, but 16 I could multiply to make with 2 and 8. And then 8 could be 2 and 4, and then 4 is 2 and 2. So if I look at the end of my factor tree, I just came up with 1, 2, 3, 4, 5 2s, and I know that I wanted to split it into 5 pieces because this was 32 to the power of 1/5. So one of those numbers would be my answer, okay? So this is how you can do it using a factor tree. Again, I'm hoping that you don't have to do this for every single number, because once you've worked with some of these numbers enough, you'll know them off the top of your head. And then last but not least, you can do these on the calculator, but there's a reason I saved that for last, and I'll show you in just a minute. So if I wanted to just type in 32 to the power of 1/5, I could do 32 to the power, so you can see my buttons here, to the power of, now on this calculator, because it gave me the cursor up in the corner there, I can just type in 1 divided by 5, and that should give me my answer of 2. On some of the calculators, let me see if I can open one here. Some of the calculators, you're going to have to use parentheses around that 1/5. Let me show you what I mean here. So like on this calculator, I would have to go 32 to the power of, and then if your cursor just stays right there, you would need parentheses around the 1/5, okay, to find your answer of 2. Sorry, that screen's not real great, but it proved my point. Okay, so the reason I saved this calculator piece for last is you are going to have to know how to do these without a calculator. And all 3 of these methods are really going to work well for you without a calculator. Okay. Sometimes the factor trees are kind of tricky without a calculator, but usually if you can divide by 2s and 3s, you should be okay. Guess and check is sometimes a little harder without a calculator, but I'm really hoping that you are able to memorize quite a few of these. Okay, not all of them. You know, and the ones that you can't memorize, you can always do this method for. So let's talk about what happens in some weird situations with these factor trees. So we're just going to practice factor trees here. Actually, why don't you take a second and pause the video and see if you can make factor trees for each of these 3 numbers. Break them down as far as they can go.